Hi everyone, in this video we are going to talk about acids. So now you may have heard of acids and bases before, but what we're going to do in this video is just focus on acids, but more importantly we're going to try to distinguish the difference between a strong and a weak acid. But in order to do that, we absolutely have to be all on the same page with our definition of an acid. And the reason I'm saying that in that way is because there's so many different definitions of acids. So if you go online and Google this, you're going to get tons of different definitions. So an Arrhenius acid, a Bronson-Lowry acid, so on and so forth. And so what we're going to do is use this definition right here for our course. So an acid in our course is a compound that releases either H plus or H3O plus ions in aqueous solutions. So all we're saying is that if we take a solute, so a solid, we dissolve it in the solvent water, if that solute releases H plus or H3O plus ions, we're going to call it an acid. And simple as that. Okay, so very simple definition. Now, how do you know if you're interacting with an acid? Well, if you're interacting with a fairly weak acid and you taste it, it's going to taste very, very sour to you. So our classic example of this would be if you've eaten a lemon. And so we all know lemons have citric acid in there and it tastes very sour. Same thing with a lime. Another thing is that if you interact with acid very, very strong with high molarity acid, it can actually burn your skin. And so you may have heard, depending on if you read the news or not, but a lot of times people actually use acid in hate crimes, and this happens a lot over on the eastern side of the planet. And so usually what happens is this. Sometimes have to do with women who they believe are immodestly dressed, and so they end up throwing sulfuric acid or mixtures of acids on these women's face, and it literally melts the skin right off your face. It is such a gruesome and cruel crime. It's absolutely terrible, but I just want to give you a little context. So if you ever hear of those hate crimes, that's what's happening. They're throwing a strong acid on there, and it literally just eats the skin right off. It's so sad. It's so sad. And the last thing I want to point out is that we have stomach acid. So in our stomach, if you recall from previous units, we have something called gastric acid in our stomach, which is primarily hydrochloric acid. And so that's what eats everything up and it decomposes our food to make it so that we can break it apart and get the fats we need, or the carbs, or the protein, or whatever it is that we need. So now, in order to talk about an acid, we have to talk about that H3O plus ion I referred to before. And so hopefully you remember from our polyatomic ion video that we have something called the hydronium ion. And this is H3O plus. This is the true ion. This is what indicates that you have an acid. Now, shorthand of this is H plus. So a lot of times you're going to see lazy chemists or lazy scientists just write H plus, but they really mean the hydronium ion. So you need to be careful and you need to make sure you understand both. But the big thing with the hydronium ion is right away it indicates that there's some kind of acid present in your reaction. So always be on the lookout. If you're doing acid-based chemistry, watch for that hydronium ion and watch for that H plus. Now, I said earlier that we're trying to distinguish the difference between a strong and a weak acid. So let's start off with a strong acid because that's the easiest one to understand. So a strong acid is simply an acid that completely, okay, so entirely dissociates in water. Okay, so 100% dissociation. When I say completely, I literally mean 100% dissociation. And so what that means is that we have 3 different strong acids that you just need to memorize. These 3 are your strong ones that you just have to know. Okay, and I'm going to expect you from here on out that if you ever see these, you know automatically that they're strong acids. HCl is hydrochloric acid. Very strong acid. Usually this occurs naturally at about 12 molar, so that's very potent. You do not want to get HCl on you. I used to work with it in grad school a lot, and I'd have to heat it up and boil it, and every once in a while I would breathe it in, and it stings in your lungs so badly. It really hurts. You don't want to mess around with this. The next one is nitric acid. Nitric acid is also really, really bad. I don't like it at all. I don't like working with it. Sulfuric acid, this is the one I was telling you about earlier. Usually this is the one that's used in hate crimes, and that's because it's unbelievably concentrated. I believe you can get sulfuric acid all the way up to about 18 molar, so it's really nasty stuff. You want to avoid that at all costs. So now, what does it mean to be a strong acid? Yes, these 3 are definitely strong acids, but what does that actually mean? Well, in a microscopic picture, I guess, we could say that HCl, when put into water, will break 100% up into H plus and Cl minus. See how we're using that H plus here? It's just easier. It makes more sense. So we break it apart into H plus and Cl minus. This diagram that I have right here shows that it's fully dissociated, okay? Let's do the same thing with nitric acid, HNO3. If we dissolve that in water, it fully dissociates. So you get H plus and NO3 minus. And so when I say fully dissociates, what you should be thinking is that it just completely breaks apart into its cations and anions. So sulfuric acid is the trickier one because there's two hydrogens, so don't get tripped up. All that means is you break it apart into the H plus and then your SO4 2 minus, so your sulfate. But there's two hydrogens, so all you have to do is put a 2 right here. That's it. But just remember, you have to balance that equation. So these are our 3 examples of strong acids. Everything else in this course is going to be considered a weak acid. So if I say anything else except for hydrochloric, nitric, or sulfuric, it's going to be a weak acid. Everything else, these 3 are your strong acids. So now, what is a weak acid? A weak acid is simply an acid that remains partially intact in water. Okay? Partially intact could mean 99.99% dissociation, okay? So we have to be, but it just, as long as it has just that 0.1 or 0.01% that remains intact, it's considered a weak acid. So that's kind of a weird thing for students to wrap their brains around, but you just have to make sure you know, strong is 100%, weak is anything else, okay? Anything else. So now, what happens when you have a weak acid? How do you actually draw it out? Well, a common one we use to talk about it is carbonic acid, and so we have H2CO3, and we're going to dissolve this in H2O. Now, if it was a strong acid, let me write this out here so you can just see the difference. If it was a strong acid, you would automatically say it breaks apart into the H plus and then the carbonate ion. We obviously have to balance it because there's 2 hydrogens here, so we would put this. This indicates that it's a strong acid, but we know that this is not one of our 3, so this is not what's going to happen at all. Instead, what happens is we get an H plus and HCO3 minus. So 1 hydrogen comes off, not both hydrogens, just 1. So this part right here is still partially intact. The acid is still partially together. That component is what indicates that it's a weak acid. So you must be able to do this, okay? I really hope you can do this. Practice, practice, practice. Last thing I'm going to leave you with is I want to know, what is the name of H3O+? What's the name of it? Go. Did you get an answer? Hopefully you did. I think this was an easiest one because we've talked about it before, but it is definitely called the hydronium ion. If you ever see the hydronium ion, you know immediately that you are dealing with an acid. Have a great week. Take care of yourself. Don't drink acids.